Well, in Houston, I'm John Herder. It's Tuesday, the 7th day of March. Great as always to have you along, everybody. In a nutshell, From the Experts is a virtual networking opportunity flow accelerator, helping leaders across industries connect very quickly in a brief, moderated, interactive show format. It's like a TED Talk with interaction. So what's in it for you? The FTE promise: if all goes well, your curiosity sparked, new ideas accelerate into action, and you may have helped yourself or somebody else solve the problem, make the connection, reaching the opportunity faster. The Energy Transition Channel show is brought to you by the Endeavor Institute, experts at developing transformational leaders for the future. Folks, help me welcome guest expert Kevin Mullen. Kevin is an experienced financial executive and business model strategist. He's raised millions for early stage technology companies, supporting management team development, tax reporting, and access to capital. In VP Finance and CFO roles, he's helped companies in fuel distribution, oil and gas, and sauce technology sectors. They've helped them navigate through challenging financial periods, building Kevin's strong reputation for results and exceptional aptitude in business and financial modeling. In 2019, while contemplating which project to take on next, Kevin came to a turning point, and he decided that contributing to solving clean energy was very important, which he considered to be an industry ecosystem structural problem. Well, Kevin, here we are 4 years later, closing in on a new geothermal power plant solution. Gosh, we're grateful that you could stop in, connect, and share your insights with the FTE network today. Kevin?
Thanks, John, and thanks everyone for logging on here and being part of the conversation. Certainly our journey started in 2019 when we discovered that small hydro assets were being discarded by utilities in North America. I dug into it. I found there's like 2,000 small hydro assets in the same situation. So it's fairly dysfunctional because utilities were on the one hand scrambling for clean energy assets, and on the other hand discarding tens of millions of dollars worth of assets, which could have been profitably refurbished. So that's what really drew my attention, and made me realize it's largely a modeling an ecosystem problem, and it was North America wide, not isolated to one or two utilities, but kind of a widespread ecosystem problem. It makes sense, no doubt, to the utilities, but outside looking in didn't make a lot of sense. So that drew my attention, and I asked my brother if, my brother and co-founder is an accomplished engineer and has done huge projects, bringing in many technologies into one solution. And I said, look, I've got the finance and modeling expertise, and you've got the ability to bring together complex technology solutions. Let's see if we can kind of shake the snow globe and come up with a different way of doing it that's going to accelerate progress a decade or two. Kind of jump ahead of the line a little bit, like Tesla or SpaceX, right? Just jump ahead a little bit, not necessarily follow the tradition of the evolution. So I guess what I'd like to do right now, John told me I'm a slow talker because I'm from Atlantic Canada. So I just want to jump in a little bit with our slide to follow through, and I'm going to talk really fast through this so that we can get down to the technology nuts and bolts at the end. So when we created GreenQuest Power, what's important to it is our philosophy allows us to think differently. So we're not focused on maximizing profit or bottlenecking a technology. We're focused on solving a global problem or a global challenge, which is clean energy assets. And we found initially in the research, we found that the price points right now in energy are such that we can do best practice from top to bottom. So we can treat all of the stakeholders, the communities, indigenous communities. We can treat everyone with respect, financially reward everyone, hold high environmental standards, and we can also invest significantly in technology solutions. So when we realized that, we said, well, we can really kind of rethink what the barriers are right now. Then we needed to design what our objective in a clean energy asset would be. So how are we, thinking about what it is we're trying to solve or come up with? So we want a solution that can be located anywhere. So, hydro plants are great clean energy assets, but you need a very large watershed and you need to be able to change the environment. Traditional geothermal, you need a hot zone. So we wanted something that was a global solution so that we include, more of the populated world. We wanted, nothing against wind or solar, but that's not the solution we were after. We wanted something that was stable and baseload capable, non-polluting, reliable, small footprint, and cost competitive. So we wanted to be competitive with natural gas, oil, or coal. So when we were looking at that, we realized that some geothermal projects currently check all of the boxes except for location. Right. And so that was kind of our mindset going in is, okay, how do we jump from hot zone only geothermal to something that can be implemented globally? And so this time, I think, John, you wanted to hop on there and run a poll.
There she goes.
Awesome.
Yeah, you can keep talking. And by the way, everybody, go ahead and mute yourself. So while you're taking the poll, Kevin, keep rolling, and I'll post the answers when they come out.
Okay. So continuing the conversation, so Department of Energy and the International Development Bank and several major political players are really jumping on to geothermal now and recognizing potential. So Department of Energy in January announced $283 million of investment to kind of accelerate geothermal development. 155 million of that is for transitioning best practice and talent from oil and gas into geothermal. And why are they doing that? Well, there's so many categories where oil and gas has been, the industry advancing the technology that geothermal will now use and build upon. So the most common type of geothermal development today, where we have huge companies like Fervo, really driving that development, is fracking or engineered enhanced geothermal systems. There's a few names for it. And essentially that's injecting a geofluid like water into porous rock or fractured rock and pumping up the geofluid once it's hot. And the reason they're doing that is to create more surface area contact and thermal conductivity into the geofluid. And so this is something that can work in hot zones, at shallower depths of, say, a couple kilometers, 2 or 3 kilometers. And you can drop enough heat to run an organic Rankine cycle power plant. That is a great solution. I think it's got a great future ahead of it in hot zones. That is a little different than what we're looking for, because we don't want to be restricted to hot zones. And we also want a closed system where we can have more control of all of the technical factors and have a longer life of asset. So we're moving past that one. We'll take a look at what Ever's solution is. Now, Ever is a leader in closed loop geothermal systems. So their approach is to drill down to the heat and build a radiator to create a surface area for the thermal conductivity. And they use a cold pipe on the way down and a hot pipe on the way up to the surface. They're using a geothermal fluid, people are calling it, which they keep to themselves. But let's say it's something like supercritical carbon dioxide, and it flows itself to the surface when it's heated. So not a lot of pumping required, if any. And this is this very aligns with our approach, except that they're so far, their deepest project is 6 kilometers in New Mexico. So they went 6 kilometers, built a radiator, got around 220, 240 degrees. So they're focusing on hot zones, but even so, they've adopted this philosophy where they're trying to create a linear or sublinear cost of drilling. So every meter, the deeper they go, it's going to cost them the same no matter how deep they go, or it'll even cost them less the deeper they go. So that is something that we have adopted as well. Where we differ a little bit from Ever is, first of all, we're not focused on hot zones. And second of all, because we're all in on the linear or sublinear drilling cost, we're more aligned with Greenfire's approach of a pipe inside a pipe, where there's cold on the outside, and then there's an inside pipe with that collects the hot fluid and brings it to the surface. Another element, of course, that most are well aware of on this call would be binary organic Rankine cycle plants, which is now a cookie cutter solution for 20 to 40 megawatt kind of grid size plants. So if we look at how it works, basically the hot fluid comes into the heat exchanger and heats up a fluid, an organic fluid like butane, which expands, drives the turbine, and then cools and comes back to the heat exchanger. So there's a closed loop on the surface, and of course we're aligned with a closed loop downhole, and we're also aligned with kind of a modular approach. So here, there's so many people from Texas that signed up today. We took a small company from Texas, Criterion. They're looking at 20 megawatt components, and they'll just keep adding 20 megawatt components to get to the size they want. And that strategy seems to be catching on. And so Sonoma County in California, for example, just awarded 3 companies 20 megawatt pilots, and they'll keep adding these kind of 20 or 40 megawatt components to scale up to 200 megawatts each. And so those 3 companies, Chevron, Circ, and Ever, 3 well-known companies, won those contracts, and they're taking that modular approach that we kind of have adopted as well. So what do we need to bring geothermal from a hot zone only solution to geothermal anywhere solution? Well, we need a closed loop system on the surface, a closed loop system downhole. That's so that we can reduce the cost of money by having a very predictable system. We also need to be able to drill to roughly 15 kilometers. Why? Because at, say, 20 degrees Celsius per kilometer, we would need about 15 kilometers to reach 300 degrees. Now, 300 degrees Celsius is a much less expensive temperature to be dealing with, both in terms of your downhole costs, and also even the surface costs with your organic Rankine cycle plant. Both are much more efficient at 300 degrees Celsius. So in order to drill 15 kilometers, you can't tolerate any technical bottlenecks, like mudding, for example. Right now, it's bottleneck at 6 to 8 kilometers. We need to be using technologies that are linear or sublinear in cost, so that we can't use or rely on technologies that are going to be much more expensive the deeper you go. We need a reliable speed, and we want fixed cost per meter contracts, again, for cost of money. The main cost in renewable energy assets is the cost of money. There's low operating and maintenance cost. The cost of money is the main expense. And we can carry that further and ensure those projects to really suppress or keep the cost of money low. So what do we have so far? Well, we have a closed system available, both for the power plant and for the downhole tech. We unfortunately have bottlenecks to drilling deeper. We are not achieving linear cost. We have advanced drilling tech that is very, very fast, sometimes achieving 5 to 10 times, traditional speeds. So the speed is really improving lately. And some advanced drilling tech companies are offering fixed cost per meter contracts. And the insurance companies have not really jumped on board yet, but they're looking. Okay. And anyone who's interested in the insurance side can reach out to me later. However, if we're talking about 15 kilometers, well, obviously we don't have reliable speed to 15 kilometers, and we can't get a fixed cost per meter contract to 15 kilometers. No one's drilling that deep yet. So if we're taking this kind of strategic approach to development, or jumping ahead of the queue a little bit and creating a global solution instead of a hot zone solution, what's the approach GreenQuest Power is using? Well, we're going to identify the technology barriers, design a financial model with a workable engineering budget, a very large engineering budget, and to optimize the technology solutions, both from in-industry tech and outside industry tech. And then we're going to locate regions where there's a strong need for clean energy at the price point that's workable in our financial model. So we're saying, look, we're working it backwards, and we're saying that this is what we can do at this price. Instead, we're saying this is what we need to advance, right? And then we're looking for that situation or that scenario politically to accomplish that. And then we initiate the project. Now, our preference when we initiate the project is to start with a commitment for a long-term power purchase agreement, because that eliminates some of the risk and a lot of the cost in these types of projects, or the risk profile. So if we can start with the power purchase agreement, that's ideal. And then we jump into the design. However, obviously in the design, we have to have an idea of how we're replacing the technology barriers with other technologies, and then proceed into design. So that being said, today I'm really happy that we were able to get some leaders together in the industry and start a conversation, and open a conversation, maybe some relationships where we can talk about these different technology challenges that we're going to face to be able to drill 15 kilometers. When we can drill 15 kilometers cheaper and faster and reliably with insured contracts, geothermal will be an ideal clean energy solution globally.
Got it. Kevin, thank you very much. So let's go ahead and post that, the results here. Take a look at that. And we've got quite a few questions that are queuing up. And so what I'd like to do is kind of go back to that. Let's see here. And you, Kevin, when you got any comments on the poll, go ahead and go for it. Skills, Brian's talking about, he's got the feeling that geothermal gradually runs out of gas cooling off over a few years. It requires moving to another site again, where the delta T is maxed out again, and then allowing original site rebuild temperature profile. Has this been improved upon?
Sorry, can you run that by me again?
Yeah, it's okay. So we've got a bunch of questions. Brian's saying, do your wells get cool and you have to move to new wells and let them regenerate?
Well, the approach that we're taking is a closed loop system. So all the fluid is inside a pipe. We're not trying to tap into a reservoir or a well at all. Okay. It's just a pipe into a dry, hot rock.
Got it. Then you've got Trent. He says, do you think that open reservoir geothermal EGS is limited to hotspots?
Yes. Yeah. So in the financial modeling so far, it is, and I think it makes the most sense there, because if you can drill deeper, with a linear or sublinear cost, then another model is going to make more sense at that point. So where, in like Texas or New Mexico or Nevada or wherever, where you can reach a 40 degrees per kilometer geothermal gradient,
right?
Yeah, it's going to make a lot of sense. Or in California, or volcanic area or hot springs or whatnot.
Got it.
But if you have to drill 10 kilometers, you might as well use a different technology.
So and pull down your presentation, would you, so we can see the whole screen? Sure. But then Steve Sharp is saying, is this actually considered safe energy production? Kind of a broader question.
Yes, at this point, you've got modeling and data available. So you're just pulling off the fluid dynamics and the modeling that's being provided by the tech leaders. Greenfire and Ever are two that we're really watching very closely.
Yeah, great. So, well, let's go ahead and open the floor. We have a few more questions. But folks, if you're new to the FTE show, we always start with this group discussion question that our expert has for you, just to get the conversation rolling. But also feel free to ask your own questions and share the experience that you have with the group briefly, 30 seconds, so we can keep the discussion interactive. Just use the raise your hand button in the toolbox there on the bottom, and we'll call on you. Hey, and if we call on you, you're also welcome to say, hey, pass, and we'll move on. So please give your name and who you're with before you decide to share, and keep the chat box active and moving on. So here's Kevin's question for the group here. I'm going to cut and paste it in there. I can get there real quick. It is, generally speaking, what do you think the most significant barrier to geothermal becoming an affordable clean energy solution is globally? Any thoughts on that? Please raise your hand. And y'all help me if I'm not catching everybody's hands when they're up. Then we have another question, which is down here. It's from Marco Adzik. He's asking, well, what is your general opinion to drilling 2 wells with long horizontal section, collision at the end, and make closed loop? That may be too technical for you, Kevin. I don't know.
No, I mean, like, we're seeing that, right? It's being done. Again, I think it just depends. If you're achieving linear sublinear drilling cost,
right,
then maybe that's not a solution. But in the interim, it's a solution because we don't have linear costs. So at a certain point of a depth in your financial modeling, it's going to be less expensive to go horizontally, right? And maybe to push through rock to increase your surface area. And whether you're doing it through injection or you have a closed loop doing it like Ever builds a radiator, but it's basically the same idea. And there are many other companies doing that idea of moving horizontally at a certain depth. So I think the difference with us is that we're focused on solving that kind of linear or sublinear cost of drilling so that we can open up a different financial model.
Got it. We've got David Gilman asking, what are your thoughts on the financial trade-offs of reducing in deeper, lower temp gradient areas versus improving grid connection from those high temp gradient locations? Did you catch that?
Yeah. I'm just trying to get my head around the question. So,
David, go ahead and just kind of critique that a little bit more for him.
Oh, I see. The transmission, yeah. I think like in terms of a global solution, I think the global solution is, financially, if you're talking about your creating a global solution, really it has to be more domestic than saying you're going to build transmission from hot zones to cold zones. I think it's just about how far do you want to go down the line in terms of being a global solution? I think so. In some cases, yeah, it's going to make sense. Build, you've got a hot zone and you can build to a neighboring cooler zone. And that transmission, is going to make sense, especially today. We have, we have evolved our transmission, so we have less loss. So it can make sense. And it's just not what we're focused. It's not the question we're solving.
Got it.
So what we're trying to solve is to be able to build this in everyone's backyard and it to be competitive with the cost of natural gas.
Trent, would you go ahead with your question, please?
Yeah, sure. Thanks, Kevin, for your talk. I've been in geothermal, maybe unlike a lot of people on this call. I've been in geothermal for 16 years. I've been at Altarock and Cirque, and very familiar with all these different solutions. DOE just did a study showing it's pretty hard with closed loop to get low levelized cost of electricity down below 100 or even higher per megawatt hour. I'm just curious, and you know, your well, because it's just going to be conductive heat flow to the closed loop, is going to cool off pretty quickly. You're going to produce temperature fluids much cooler than the rock temperature because of that. So I was just kind of curious what levelized cost of electricity you've calculated, and if you could share that or not. And then, you know, how do you deal with the cooling that you're going to see due to conductive, you know, rocks are not conductive, rocks are insulators. So that's a kind of an issue.
Yeah, so I saw someone brought up kind of the diameter of the pipe. That's one of the surface area solutions. And the other thing too, that kind of aligns with what you're talking about, Trent, is that when you have a linear or sublinear cost of drilling, you can just go straight down, and that solves a lot of that thermal conductivity issue for how much heat you can draw from the rock. And so you're going into hotter and hotter rock, and while you're creating your surface area. So that's you know, so we're insulating down to a temperature point, and then any additional surface area that we need, we just keep drilling straight down to accomplish that. And I'm not saying that we'll never build a radiator at the bottom, but chances are, you know, if we're hitting linear or sublinear cost, the most efficient way to create that surface area is just drilling straight down.
So we've got another question. Lee Erickson says, have you had any discussions with drilling technology companies about developing downhole tools bits for this extreme temperature at depths that you've mentioned?
Yes, we have, and we're always reaching out and trying to talk to more people because that essentially is a huge part of what we're doing. So, you know, we don't want to stop to stop for 12 hours to replace a drill bit, you know, or 18 hours, or depending on how deep we are, you know, like we'd like to be able to do our repairs and maintenance downhole. We would like to really limit the wear and tear, and so we're looking at everything from AI solutions to drill bit design. We're looking at the power source downhole. We're looking at mudding. Is there a solution to replace mudding? So we're looking at some pretty different ways of making drilling faster, more predictable, and much less expensive.
I think it's fair to say, Kevin, part of what's happening here is you're looking for partners in these kinds of areas. So for everybody out there, if you've got something that you want to talk to GreenQuest about, or reach out to Kevin afterwards. Gene Beck, you had your hand up, sir.
Yeah, thanks, Kevin, for a great talk. I like the slides you put up, you know, showing all the problems. So having been a driller for years and drilled a lot of deep wells, I appreciate your challenge of linear drilling costs, because, you know, that doesn't exist in the oil field, right? They're completely nonlinear. The deeper you get, the more it costs. Have you given any thought to rock destruction technology that goes beyond the typical oil field drill bit design, where, you know, you're basically shearing or crushing the rock one way or another? Are there other technologies, laser technologies, things like that, that could be a game changer for your linear cost development?
Yeah, there's some amazing technologies coming out yet. Maybe not quite commercially ready, but they're getting close. So, you know, Quasi is using a wave to vaporize rock. I don't think they've really got to the point where they figure out how to get the dust out of the hole, but they're working on it. And they have projects lined up, so they'll be coming in. And at a certain point, they may be the most efficient technology to use at a certain phase of a hole. There's a rocket scientist working on right now shooting small explosive capsules past a drill bit into a rock to charge the rock with energy so it breaks apart easier. And he's accomplishing a much faster drilling rate in hard rock. So there are some very interesting approaches to doing that we're keeping our eye on and talking with.
Very good. Thank you.
Folks, any other questions out there? Edgar Velez, are you out there? Are other folks that are deeper into the geothermal side from their experience? What are some of your thoughts on what you've heard? I see that Geyer Carlson is asking about any engagements that you've had with the Icelandic technology or geothermal projects.
We actually haven't reached out to, there are major players there, of course, and drilling companies. So that's a connection we haven't made yet.
So Matt Bell just sent over something with regards to projectile drilling. It's in the chat. You guys can get a copy of that. Bill Westbury mentioned something about a DOE project back in Houston. We already talked about Hans Inge. Talk about on the finance side of technology, getting this new tech together. What are your thoughts there?
Hey, John, how are you?
Good to see you.
So I haven't heard all the discussion because I've been a little bit back and forth, but on the financing side, I know from the Norwegian side, we have a different type of research grants for, the initial R&D as well as piloting. And I think there's only been one in the last call, at least, the geothermal project. And I think that was a pipe-in-pipe type solution. And then that was for the Norwegian Research Council. And with regards to Innovation Norway, we have a green platform program. A lot is about ammonia, hydrogen, obviously, zero emission maritime solutions, etc. But there has also been geothermal. My thoughts on that from a Norwegian angle is that our bedrock is not that well suited for it. Although offshore, obviously, we know a lot about the reservoirs. We know a lot about the temperatures, etc. So that could be an opportunity. Seems like the US have some extremely good funding programs. In my view, those were the best out there. So I think Texas is probably a good spot to be with regards to developing geothermal technologies as well.
Yeah, it's an interesting topic. My creativity is usually on the financial side, and piecing the pieces together. And I noticed that some regions really now with the many regions are going to have a doubling of their demand for electricity over the next 10 to 15 years. And they really don't have any solutions because the surrounding regions they normally rely on are busy trying to meet their own supply requirements. And so they're unable to lock this in. And what that does, it means that the price point where you can come in with the best solution is much different than it was 10 years ago. And that's really an important part of the logic of what we're doing. We're saying, look, where we identify that someone can pay, and someone mentioned $100 a megawatt hour, right? If someone can pay $100 a megawatt hour, okay, how are we going to allocate that? And what does the power purchase agreement look like that would facilitate a very large engineering budget where you can go not only inside your industry, but reach out to other industries, pull in the best tech possible into a drilling assembly to create an optimal solution. And what we realize is there's a lot of room for shaking the snow globe a little bit, stirring the soup or mixing the salad, whatever you want to call it. If we can mix up the order in which things happen, it can really reduce the cost, because a lot of the cost in these projects is related to risk. And so if you can change the order in these needy regions, not to I don't want to sound facetious. I'm just saying, regions that really don't have a solution yet. And we can say, look, it's no risk for you to sign a PPA at this price point. It's the best option that you have available.
How do you make
And
this representative?
then,
On the
we
bottom,
take
okay,
that, and instead of just building, what everyone else is building, we create a budget for a few $100 million of engineering. And we build that ideal AI, machine learning, IoT sensor package that helps reduce wear and tear on the drill bit, for example. Maybe we change the power source to electric downhole. We have the capacity right now to be electric downhole. It's just nobody is doing it, right? Why? Well, because, we're using mudding, really. And so if we look at a combination of technologies that can come in and replace some of the technology barriers like mudding, maybe we can get to that affordable 15-kilometer price point, as long as we have the money to do it profitably in one project.
Got it.
And so we kind of flipped the script and we said, look, let's create a profitable financial model, and then attract the government into it to participate at whatever level that they want to participate. So we would love if the Canadian government, for example, would come in and drop down $100 million to reduce the risk profile of our first hole. We would love that, but they're much more likely to do that when we have everything else in place.
Got it. Thanks, Kevin. So if you guys have questions, raise your hand. I've got one over here from Robert Knoll. Robert, good to see you. Looks like, Robert, are you still there? Okay, it looks like.
Yes, I'm here. Can you hear me?
Yeah, go for it.
Great. It'll be quick, and it's more on the residential kind of side of real estate, and this product becoming more affordable for apartment complex, multifamily use, things like that. For the idea initially I heard about was really dealing with AC control, but always looking for a way to cut energy costs like that. So what's your thoughts around that?
Yeah, I think eventually it may get to that point. So, the warmer zone you're in, the quicker it obviously, and if you're talking about air conditioning, the warmer zone you're in, the quicker it can reach that point. So to go in and drill and operate, say, a 20 megawatt unit. So let's just throw a number out there, 20,000 homes, if you're powering 20,000 units, then I think that, by 2035, we may be at the point where you can go in and do that, and take a small suburb or something like that and be an efficient power source for a suburb. This is a very stable source of energy, right? So it's very useful, and there are undoubtedly financial models where that's going to work. But to get it down to 500 doors, I don't know how long it'll take to get to that point. But if you're talking 15,000-20,000 doors, maybe.
Thanks.
I'm going to pick on Tiffany Watson. Tiffany, you're in projects with Calpine and geothermal, I think, as a part of your area. What are you seeing from your perspective? And then I've got Tiffany, while you're coming on, I see Lee Erickson sent out a good example of government-funded geothermal drilling in the link below, so you guys can grab that. And then Joffrey was asking, is there risk of earthquakes related to geothermal, this drilling? Kevin?
Yeah, there definitely is, to a certain degree. You tend to know the landscape that you're going into. So if you're close to a fault line, it's definitely much larger consideration. Part of our strategy is, if there's a shift of a few inches, then which is substantial, and if there's a shift downhole of a few inches, how can we deal with that? So that's part of the tech that we want to be very versatile downhole. So if there's any damage or blowout or anything, we want to be able to go in and repair it efficiently.
Dimitri, do you have anything to share from your perspective, from your geothermal work? Tiffany, are you there? Any of you guys want to?
Yeah, guys, thanks a lot. To be honest, I didn't have a chance to see the full presentation. I was just going through the slides, and I really like idea. But I mean, my background is oil and gas, correct? I'm coming from, and I spent quite a lot of time in oil and gas in Middle East, especially. And we've been drilling probably the longest, not the deepest, but the longest wells, definitely. And most of the time we limited somewhere around 2 to 3 kilometers. I know the deepest project right now worldwide, it's located in Russia, in Sakhalin. I think it's around 11 kilometers or 12, if I'm not mistaken.
Well,
It's a Kolskaya ultra deep. But I mean, this project took like 20 or 30 years with different technology, but I mean, the technology limitations was there. And right now, probably it's the same. So for me, I think the biggest challenge here is technology limitations and the cost to develop this technology. Because looking in oil and gas, I mean, every new leap of technology, it's just enormous investments, and you trying to open the new way, a new like called direction in drilling. Because going so deep, you will encounter quite a multiple challenges, which will be quite costly to resolve. So I think this is for me is a key challenge of this direction, especially
Yeah,
the
I
depth
agree with
and
you.
the material.
Right.
I agree with you, Dimitri, and kind of what we're saying is, similar to Tesla and SpaceX. It's, there is technology available that's not being used or hasn't been incorporated yet that could replace some of these bottlenecks. And we just need a project that's large enough and designed in such a way that it satisfies all the stakeholders with a large engineering budget. And we don't need to create new underlying technologies. What we need to do is implement existing technologies to solve problems.
Right.
So I agree with you in what you're saying. I will say that, in China, for example, right now, there's a lot of drilling happening at that 7-8 kilometer depth. And, Ever, was a Canadian company, just finished a 6 kilometer plus hole in New Mexico. So that's about where we're at right now, in the 6 to 8 kilometer zone, comfortably. And I think what we're saying is it's pretty obvious right now what the bottlenecks are, and someone needs to create a project where we just solve those bottlenecks in order to open up, the rest of the world to geothermal. Geothermal is such a good energy source,
Right.
that if we can solve that problem, it's worth the investment.
So,
That's our
we're coming in the end of time. Bill Camella, what are you thinking about? You're hearing all this. You're a drilling technology guy. What comes to your mind here? Caught you off guard with your mute on. But as you're doing that, I see Craig Dunn has asked, why the focus on anywhere perspective, Kevin, for the application when there's a wealth of hot geothermal opportunities that have yet to be developed?
So, John, I do have my unmute working now. So actually, the big question I have just goes back to what Brian Skeels was asking and Trenton was also asking, and that's on the rock cooling. So even if you do solve this problem of getting down to extremely deep wells, I've been working a couple years now looking at different models, and when you start producing that heat in a confined loop system, the rock around that well gets cooled off, and pretty cool within a few weeks, unless you really slow down your flow rate. And then the time, someone was asking how long it takes to rebuild. some of the modeling will show that once you have a cooled zone of some meters away from the well, that it can take decades to reheat. So I think it's not just a matter of getting down to that depth, but getting down to that depth at a low cost. I know the DOE now have funding opportunities where they're trying to look at, reducing those costs by 90%. And I think that's what you probably need to make this work in the future.
Yeah,
Unless there's some other way
it's an interesting part of the technology challenge in calculating the thermal flow rates, through the rock, and how far apart do your holes need to be, and how deep do you need to be, how much surface area do you need. So the good thing about it is that to a certain degree, it's something that can be calculated. And I think the deeper that you go, the more that the thermal conductivity acts the same with different types of rocks. So those are important factors that we're looking at and kind of studying the science behind that. So like you were saying, hey, it would be great if we could get the government to, front end a lot of the risk profile in the projects where we're figuring this out. I think it comes back to the reward is large enough that it really justifies the investment to figure out these problems, because in the end, it's stable, very small footprint, no emissions, it's low environmental impact. It's like everything everyone wants in a clean energy asset. So we're saying these are, engineerable challenges, and we should make the investment and solve it, because it truly becomes a global solution when we can do that.
Well, thanks, Kevin. And that's going to have to be the last word on this FTE show. So, folks, how was the expert talk and discussion today? I've just turned on the FTE survey poll. Please take it. It helps us get better. And reminder that today's post show notes will be hitting your inbox pretty soon. And if you'd like a copy of the attendee contact list, show transcript summary, or maybe a personal introduction to specific show attendees, well, let us know in the survey and we'll send out a membership link so that you can get access to what you need. Making authentic connections, expanding your networks has never been more important to your business. So next up on it from the experts, what is your change IQ? Did you know that 75% change pursuits don't actually succeed? Well, on March 28th, we have Energy Innova CEO Marissa McKillis. She demystifies the change adoption and shares best practices reducing change risk to your business. Then S&P Global Commodity Insights hydrogen pricing analyst Santiago Soria comes on talking about pricing model concepts for low carbon hydrogen and ammonia. Then we have Google sustainability and energy transition lead Trinity Lloyd. She shares how they're rapidly applying big data and technology to create affordable low carbon power solutions for community and business ecosystems at scale around the world. And last on the docket, Siranor co-founder, CEO Abhijit Inamdar talks about how they're leading the way to decarbonize the aviation industry and why hydrogen is the solution. With over 1,900 members, 20,000 followers across 25 industries, the FTE network is growing quickly, accelerating opportunity flow for you and for your business. Wondering where you fit in? Learn more about our membership packages and register for more shows like this one on our website, fte.network. Folks, we're out of time. Thank you once again, Kevin, and all of you from the experts on the FTE show. Take care.
Thanks, everyone.